What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. I'm going to be talking about today identifying like terms. So let's go ahead and get into the examples. Now, remember, for our first example, these are going to be somewhat long. So I have 3z plus 4 plus z plus 4z. Now, in order for two terms to be like terms, first of all, we need to figure out what are terms. Terms are separated by addition and subtraction signs, okay? So here I have 3z is a term, 4 is a term, z is a term, or 1z, and 4z is a term, okay? And they're separated by these 3 plus signs. Now, in order to be like terms, they have to have either no variable at all. So a constant, a number by itself, 5, 10, negative 12, 35, 22, a number by itself, they are all like terms, whether they're positive or negative. Or they have to have the same variable and exponent, okay? So they have to have the same variable and the same exponent. So if I have two terms, one has x and one has x squared, they're not like terms. In this case, 3z, 1z, and 4z are all like terms. And I like to do things like connect them like that. Or sometimes I'll put the same color under them. Or I'll put the same shape around them so that they are easily identifiable. Okay? So, like terms, remember they have the same variable. In the second example, let's say I have 2n minus n minus 4 minus 7n and then plus 12. Okay? So I have, you guessed it, 1, 2, 3, 4, 5 terms. Okay? I have 5 different terms. Now, the n terms are like terms. Notice the sign goes with the term to its right. So this is minus 7n, and that's going to be important when we start simplifying algebraic expressions. So this is minus n. So if it has no sign in front of it, it's plus or positive. So 2n minus n minus 7n. Those are all like terms. And also, I have I'm going to put something like that around these. The negative 4 and positive 12. Okay? Those are like terms as well. Okay? So we can reorder those if we wanted to simplify this, but that's not this example, or that's not this video. So our like terms, we have the ones connected in blue that just have the n, and then I have my constants in purple. They are all like terms. All right? Let's get rid of these. So remember, like terms have to have the same variable and exponent, okay? As well as they could be like terms if they are both constants. Example 3, or as I like to say, example 3. Negative x minus 9x squared plus 12x squared plus 7 minus 5x and minus 3. Okay? I'm going to do the color thing again this time. So let's start off with the x. Alright? Notice this is a negative x. Okay? So negative x is a like term with negative 5x. So let's go ahead and connect them. Woo! Alright? Then we have the x squared terms. Fortunately, they're right next to each other. So we can connect those. So that would be negative x squared plus 12x if we wanted to combine like terms. And then last but not least, we have 7 and negative 3. And they are like terms as well. Okay? And so that's our like terms. And then one last example. Let's say example 4. All right. We have 4xy squared plus 9 minus 2xy squared minus 6 and then plus 15. And let's go ahead and put an x on that 15, okay? Just to make it interesting. Now notice we have xy squared, okay? So these are like terms. 4xy squared and negative 2xy squared. Those are like terms, okay? Notice I didn't connect them to the 15x because it has to have xy squared, okay? And then we have 9 and then minus 6. Those are like terms. Notice the 15x doesn't have a like term, okay? And that's okay. Sometimes you'll have a term that doesn't have a like term. Once again, if we wanted to count these terms, 4xy squared, that's 1. 9, that's the second term. 2xy squared, that's the third term. 6 is a term, that's a fourth term. And then 15x is a fifth term, okay? So that is how you combine like terms. Remember, please do not forget, they have to have the same variable and the same exponent, or it has to be a number without a variable, okay? So that's how you combine like terms. Now, you're going to use this particular concept to build and know how to simplify algebraic expressions. Take a look at that video next.